Hi guys, so in this video we're gonna to explore how to make this type of lip. It could happen into a mold like this mold and also how we can add a lip inside a mold that has no lip inside, in this rudder for example, but it could also be handy to use in some bagged wing, bagged rudder, bagged elevator. So for example, here we have this rudder and we're gonna to learn how to make the internal hinge that will be added. The result is something like this. And we have this lip right now. And of course, we can make this lip in 3D print very easily. This is what the video is gonna to explain. We want first having this rudder. We need to know what is the length between the leading edge and the trailing edge. We ask mu0 and we start from 0 to this point, which means 110 millimeters and 495. So if we halve this number, we got 55.2475. So now we use the construct menu, point along path, and we use this line. We are missing a little bit here, but it's very teeny proportion because the line can start from 0. Oh, it's perfect. It's not exactly exact because we have a 45-degree angle here, but let's say that's okay. So we ask physical type. We are at 60.53 millimeters, and we need to remove from 0 the half code. So we need to remove almost 5 millimeters, which means that we have to start from here. We need to construct an offset line. We want the offset line to be 0. And why? Because we have something rounded and we want to know the point here. We want to have a line here. We have this line right now. So we need to put a point here that goes exactly here. So we can do the same, point along the path and try to align this point perpendicularly. If I wanted to be really exact, I would make a sketch to have a 90 degree between here and here, but we are talking about a fraction of millimeters, so it doesn't really matter. This point here is aligned with the inside surface where the real hinge articulation should be. So as you understand, we're gonna to draw a line from 0 to 0, but we have still to define a point here, and we will be able to draw this line between the 2 points. Or we can proceed of this by axis through 2 points. This one will be very handy in a few minutes, but for the moment we have to draw the second point. So I'm going to use this line rather than this one. I prefer to use this one because it's most likely that I will have more chance to have a real line contacting all the surfaces, because there will be some slight angle very likely here, and we need to find the distance again, the length of this code, and the length is 50.257, which means that's 25.28085. So let's close this point on this curve right now. It's not really exact because this is a curve, but it will be good enough to put using the construct menu point along the path. And preferentially we're gonna to start from there. We ask a physical distance type, not a proportional one, and we need to put 25, let's say 3, it will be good enough. And we have the second point. At this stage, we just need to draw this line. It's very easy. Submenu construct and axis through 2 points. You select the 2 points, this one and this one. And here it is. We have our line. If you want to check, and this is useful if you are building your wing and you want to align every section to keep your hinge straight, you will do this method, and additionally you will move every rib up and down until the rib is closing the straight line, and after you are making a sweep to create your solid. So we need to draw a second line below, and the difference between the two lines is fitting the exact thickness of the carbon fabric and also what will allow the rudder to move, which generally speaking is Kevlar or PLP. You have to know the thickness of these two fabrics, and maybe at this place you want to have two carbon fabrics rather than one, and you need to let some room, some margin between the height of your future lips, the top of the lips, and the top of the mold. So in our case, if we consider two layers of carbon fabric, it's 4 of 100 millimeters. And my PLP is less than 8 of 100 millimeters. It's very teeny. So the problem with this very teeny fabric layer is that we have almost no room for error during machining, which means the machining is wrong, slightly wrong, of let's say 1 over 10 millimeters, which is easy to achieve as error. You will have the lips touching the inside part of the mold. So you don't want this, which means that you have for safety to let more room. In my case, I'm around of 0.15 millimeters, and I will probably push it to 0.25 millimeters to be sure that the lip will not crush the opposite side of the mold. Here we go. How we do this? We select the line, we make a copy, Ctrl C, Ctrl V, and you just put it down of 0.25. Let's look what happened on this side. Okay, and now we need to make a sketch, and the top of the lips will touch this line. So we need to draw this sketch. We need to make a construction line here to pull it here approximately, because this is where we're gonna draw our sketch. So now we create a sketch. Now what we can do is try to make something a little by having a conic curve. So try to make something a little more curvy, and we are happy with the result. So I need to join here and here to close the surface. I just worry a little bit about this, trying to keep the angle equal side by side approximately. So now we have a sketch, and with this one we can cut the surface. We have to extrude here, so this is what we're gonna to do. Let's try to see what happened. And now we have a little problem because it's not a ligament. Rather than to make a cut, we're gonna to make a new body. This new body will help us tremendously to cut our surface, but we need to align everything. We need to use the align menu and we choose body. The problem here, we don't have a real line. So I will align this line with this line. Here we are. And now I will move this guy a little bit. In the middle. And a little bit here. I think we are good to go. I'm gonna have to check out. And here is okay. So we're gonna have to split this rudder, which will be the core. Before I would like to make a copy. So we use our tool. And here we are. That's our core cut with our tool. This is what we want to mill, but technically it's not possible to mill in one pieces this one if you don't have a bed with some vacuum. If you are milling a block of form of a rudder in two-side operation, top bottom, you are gonna to have some problem here because after milling one face, when you go down, the block and the core will have not enough strength to maintain and sustain itself, and it will collapse, and then the milling will be not accurate. So we need to divide this core by 2 and half it, and to mill separately one face and the other one. So easy. You just need to use this line and to construct an offset line. So we need to use construct menu, plane at an angle, and we are happy with this angle. By using this construct offset, we can easily now cut and halve our core, and we will be able to mill separately. Now we have our core halved, and we want the lips, and we want this one to be adjusted into the core, which means exactly this lips. And this lips is fitting exactly our core. Why I do this? Because I have forgotten to mill the lips into the mold. So I will build this lip with a 3D print and I will insert it into the core and put everything into the mold. So as you can see there is no lips into the mold. So you will ask me, but Guy, you put this core into your mold and you put also a lips, this one, into the core. That's okay. But when you are demolding everything, the problem is that the lip will be entrapped into the rudder. And so you cannot move the rudder. And I don't understand why I do this. The lip will be coated with a lot of molding agent and will be released. I will cut along the line with a cutter and I will open the rudder and I will get out these lips, then it will become exactly like this. So the main advantage is using a lip fabricated in 3D print means that if I'm not happy with my lip because it's not thick enough or it's too thick, I can modify it anytime. I just have to maybe redesign a little bit everything, the core, and that's all. An advantage is that this lip, depending on the feeling of my 3D printing, it could be 100%, which means that will be very stiff, but maybe it would be only 40%. So I can compress it a little bit into the mold. I will have no fear to damage my mold because if you have an internal lip into the mold like this, it means that if this edge is touching the other face of the mold, you can damage or make a dent into your mold. You need to have very high accuracy expectation if you want to be sure that nothing is dented or damaged. So I think this story of lip in 3D print integrated into the core during the molding process is quite an elegant solution because additionally you could change the angle. So if necessary, I realize that I don't have enough input control on my rudder. Maybe I need to open a little bit the rudder. I will make another lip with a more open angle. And what I have to do, just change the lip and remill another set of core. To finish, I just need to cut this one after I need to mill separately these two core and put all with the lip into the mold. So the second thing is that this lip will act as an insert. The composite walls insert are used. And this is exactly the place where an insert should be used to keep every corner, every angle with the carbon fabric to strictly stick to the core and to have something very, very neat. So I think that typically that's what this type of insert could achieve as a result. This is our lip for our hinge. It could be used in a mold or a vacuum bagged rudder, wing, elevator. Of course, here it's small enough so I can 3D print it. You will use the PETG carbon fiber filament. Why? Because this is the most stable dimensionally filament. And if your lip is too big to be printed in one part, you will have to print different parts and to assemble them, probably with some carbon rod or whatever you will find. You can also go forward and maybe you want this to be in silicone and you want to make a mold for this, so it will look like this one. And you will need a counter mold that will close this mold. So basically, this is the counter mold, and you can see here that it is embedding the lip. Of course, normally you should cut this part here because it's preventing the parts to be demolded, but I remind you that silicone, so it's likely that it will be not a problem. But normally in a mold you cannot have such angle. That's the counter mold, and this part is coming into the mold. So that's just an idea just to show you where you can go, and maybe you can make this mold in 3D print, maybe.